Welcome to the lecture series on deep learning in artificial neural networks. In this and the following lectures, we'll look at neural networks from a statistical point of view. This first video presents the questions and aims of this lecture. As always, we have a database of supervised learning in the context of classification, where we have pairs of inputs and target outputs. And in a classification task, a value t mu equal 1 may mean that this specific input pattern x mu is a car. And we have p patterns of this type. We use these database, we use these input patterns together with a target output to train our classifier. The classifier gives an actual output. What we would like to have is the actual output identical to the target output, and the classifier in our case is a neural network. As input images, we could take cars, but we can also take handwritten digits, and this is again the example of the MNIST database, where we have handwritten digits from 0 to 9 with different writers, different writing styles. On the right hand side you have many of examples. The specific example here, well, what is it? Is it a 9? Is it a 4? Well, or this one here, is it a 9 or a 4? Well, what might be a 9 for reader A might be a 4 for reader B. The people who wrote these digits said to all of these, yes, this is a 9. And so input data is noisy, training data is noisy, the labels are noisy, and that's why we do cross-validation, that's why we use regularization methods. But if this is the situation, that for this input pattern, some people would say it's a 4, some people would say it's a 9, then maybe we want our neural network to also say maybe it's a 4, maybe it's a 9. Maybe an output of this here, y hat, that says it's 0.6, maybe a y hat value 0.6 means that it's 60% that it's a 9, and it's maybe 38% that it's a 4, and then very few percents for the others. So the big question for today is, are we allowed to interpret the outputs of a neural network as a probability? And to do that, we have to take the statistical point of view. We have to say the neural network must be seen as a generative model that predicts the labels, and it does so in a probabilistic fashion. So now let's work on this. I have my input data. I always put an extra input so that I have the thresholds explicitly. And then I have my different outputs, cars or dogs or something else. And the idea is we want to interpret this output for this input mu, the y hat for mu, as the probability that this input pattern x mu should be classified as class K. And this should be true not only for the patterns in the database, but also for arbitrary novel patterns, which in my notation do not have any indices. So what we have to do to achieve this is to say, well, actually this is a continuous output, but for a generative model we have actually to add a probabilistic module at the end that generates labels, predicted labels, +1 or 0, and the +1 is generated with this probability, which is just the output value y hat. So this is the extra module that we have to add at each output of the neural network. And then we can say our output is the probability for this input that it belongs to the class. And this is actually implemented by saying the network has a certain probability to predict the class label t hat 1 equal 1. So the statistical view requires that we consider an artificial neural networks as a generative model for class labels. And so we have to add this extra module. We don't have to implement it in a simulation, but just conceptually, we have to add this extra module to say the neural network predicts a label. And this is the basis for statistical interpretation of neural networks, and this is the starting point for the following set of videos. Now, all that I will cover in the next videos is standard material, is not specific for artificial neural networks. It's part for any introduction class to machine learning, but we will discuss it in the context of neural networks, and there are classic textbooks that cover these topics very nicely.